Okay, let me solve some questions from here. There are not so many anyway. I'll solve all of them. 1, 2, 3, 4. Astrid throws dice and she records how many times she gets 1. After 30 throws, she gets 4 ones. Blah blah blah. Theoretical probability. Theoretical meaning that not experimental. Theoretical probability of getting 1 is 1/6 because dice has 6 sides. What is the experimental probability after 30 throws? Okay. After 30 throws, it says 4 ones. So 4 out of 30. Which is 2 out of 50. After 60 throws, I always simplify. After 60 throws, she has scored 9 ones. So 9 out of 60. If I simplify it, it will be 3 out of 20. After 300 throws, 45 over 300. 15 over 100, which is 3 over 20. Huh? Okay. And after 600 throws, she gets 1/4. Actually, if you see, 1/6 is actually 0.17, and this is actually 0.16. No, actually, this is 0.16 and this is 0.17 in decimals. So actually, these are very close. So my point is, more you do trials, more you get closer to theoretical probability. Do you think her dice is fair or biased? Explain your answer. Fair meaning that is it close to the real dice, which has a 1/6 possibility, or if it's something very far away. So, for example, if I have a less chance or more chance of getting 1, I wouldn't say the dice is fair. But since this, after so many throws, it gets very close to 1/6, I say this fair because it's extremely close. It's like 0.01 close. Okay, number 2. Jasmine has a bag containing some counters. She tries an experiment where she takes a counter and makes its nose of color and then puts it. Counter is like a piece of paper, different colors. She does it 100 times with these results, and she records the frequencies of different colors, as you see. So she tries to pull and then look at color, put it back. Pull, look at color, put it back. How many colors are there likely to be? Okay, so after 100 times, you see that I get some colors more. This is not a chance. This is actually, that gives me the tip that, I should have more yellow because I get it more. I should have about the same number of green and red, and I should have less blue. That's what it's probability statistics saying me. It most of the time holds. I cannot guarantee the number. I can just guess the number, but still, this after 100 trials, this gives me a good guess. So, 37 out of 100 times is the time I get yellow. 25 out of 100 times I get green. 23 out of 100 times I get red. And 15 out of 100 times I get blue. So this is actually, this gives me, or 37 out of 100 as well. This says I'm not just thinking how to construct it. In total, of course, I have yellow, green, red, and blue, and total number is 13. And 25 out of 100, 1/4 of them are actually green. So 1/4, that means 13 times this number, I have green ones. So 13 times the probability will give me the, so 13 times 37 over 100 will give me the yellow ones. I started from this one because I see that 1/4, right? 25 over 100 is 1/4, so 1/4 must be green because that's the probability given to me. 13 times 23 over 100 must be red. 13 times 15 over 100 must be blue. Let's look at those numbers now. It says 4.81. $3.25. Aye. 2.99. This is 1.95. Okay, here I need to decide the number of counters, but counters are in full numbers. There is no 4.81 counters, so I need to make it close as possible to a full number. 4.8 is close to 5. 3.25 is close to 3, closer to 3 than 4. 2.99 is close to 3. 1.95 is close to 2. So if I add it up, I have total 13 counters. So I distribute it by the probability. Since it's like 1/4, I give 1/4 of this here. It's also almost 1/4. I give 1/4 of the counters here. So the rest, depending on the possibility, I distribute it. So it's back to the same thing when I was doing the founding faulty boards, 10,000 faulty boards, my numbers. Number 3, Hamish, Shrita, and Melissa did an experiment to find the probability of spinner landing in the red section. Here are the results. Red section is here. You see red section is less than the green section. And here I cannot, I don't know the angles and stuff, so I need to decide. I need to take a look at their experiment probabilities. And maybe I can even guess angles using that. That's the good thing about probability. Whose results are likely to be most accurate? Give answer for your reason. For here, Rita's answers needs to be more accurate. Why? Because she tried more. She simply tried more times, and that will definitely give you more accurate results, and that should. Find the experimental probability. So A is Rita. B, because tried more. Find the experimental probability of landing on red using the result in the person you choose in part A, and all results add together. Okay. Part A, Rita, landing on red is 35 over 200. Or you can need to simplify it, 7 over 40. I leave it like this, I don't do decimals, okay? I leave it like this. This is for Rita. And if I use all the values of all 3 people, what will I get? In total they tried 120 plus 200 plus 50 and 22 plus 35 plus 7 times. See, all collective probability is probably better than the single person. No, syntax error. Fuck. 64 over. It gives me 0.17. I don't want to like writing decimals, but it's too much time to simplify it down. So, but it's fine. This is, and let's look at this one. Let's see if they're different. 7 over 40 is 0.175. But this has more trials, so this like the other part, the last part, will be more accurate because they include more trials. Okay, last question, number 4. 10-year-olds dice 500 times. Here are the results. Why the experiment suggests the dice is biased. Dice is biased because there's a 1 over 6, and I said, if you try it 50 times more than the possible outcomes, meaning 300 times, so if you multiply this by 50, 300 times, you should get as close as results as possible. But look at the results. Some of the numbers you get more, like 100 times, and then some of the numbers you get like 30 trials difference. This shouldn't be it. After 500 times, you should get closer. If you don't believe me, try it and then note it down. Note your counter down, because I believe this should be, not I believe, it should definitely be closer to that, because that's how probability works. It's not magic. It's not like winning the lottery. Okay, it's also probability, but you don't have that much chance. So at least like rolling 1 or rolling 2, they should be closer. Or rolling 3. Look at, there's 40 difference, 40 points difference between 2 and 3, which is unlikely in the real event. Okay, so this is, for me, this is definitely biased. If you try 500 times and get something close to this, tell me. I don't think you will try, but okay.